In this section, we'll see the different phases we need to build a better dimensional model. Okay, as you can see it on the left side of the screen, you have requirement gathering, which is the first phase, and then the conceptual model design or the conceptual data model, logical data model or the physical data model, and finally the database. Now these phases would be common in, I would say, almost all the dimensional model creation process, because this is the defined structure with which you get the proper output, with which you cover all the key business requirements whichever are in scope and come up with the physical data model with which the ETL process can be started to load the data and OLAP can generate the reports. All right, let's look at each one of them separately. Let's talk about the second phase, which is your conceptual data model or conceptual model design. Now, if you can look at the screen here, what you have here is only the placeholders, right? Only the boxes with a small title on top of it. We don't have any keys, we don't have any attributes to it, and we don't have any technical definitions which are defined here because it is still in the conceptual phase. Now, based on the business case, based on the use case which the end users have given you, we just try to identify what are the different entities which should be available as part of your data model, right? So this data model should include all major entities, their relationships with each other, and as you can see, it will not contain much detail about the attributes and is often used in the initial planning phases, right? This is a rough diagram where all the stakeholders like the end users, the business users, and the functional architects and the subject matter experts sit, brainstorm it, and just come up with the things which are required for them to start with, right? Because this is the initial phase. That's where we start with the concept. Now, once you have requirements gathered, now based on the requirements which are reviewed line by line, we will come up with these standard initial planning phase, which is nothing but our conceptual model design, and just try to put as many entities as possible to cover where will it be, right? For example, your time dimension can fit in 4 or 5 different requirements, right? Your product entity can fit in 2 or 3 requirements. Your store can fit in some other number, right? So like this, it might be a number of entities which are required based on your business process and the requirements, right? So even this is documented in theory, and in some projects where you have good amount of time, this documented conceptual model is shared across with the data architects, the IT team also, just to see if it is matching to their requirements, right? Now it is too early for IT team or the architect team to comment on it, but they can still review it, right? If there is some other way of some other viewpoint from any of the team members, that can be clarified right then and there. All right, that's about the conceptual data model or conceptual model design. Let's talk about the third phase, which is the logical data model or logical model design. Now, this is the actual implementation of a conceptual model into a logical data model. Now, logical data model is the version of the model that represents all the business requirements of an organization with attributes, right? Now, as you can see the difference on the image itself, on the conceptual model, you have the top level entities. As we move on to the logical model design, we have described what should be the attributes. We didn't go to the technicalities yet, but we just mentioned what are the things which are required at the granular level for each of these entities, right? As you can look at the time dimension, it describes date, which is the primary key, and then the date description, then month's description, year, week, and week's description. Now, if you notice, there is no mention of quarter, or there is no mention of previous year or fiscal year, things like that, right? Now, those are all the common things in the time dimension. Now, as a best practice, we should have all of those. But let's say it is discussed, the topic has been raised that why don't we include the quarter as well? We might not need it now, but we might need it in the future. Instead of doing the changes then, why can't we start using it from right now? Right? Somebody from the stakeholder team or the IT team or the data architect can suggest that. If it is a good idea and if the business anticipates that there could be something like that in the future, yes, add it, right? Generate it. And especially for time dimension, it is a one-time activity in the whole year, right? And nowadays you can get all the content which is available on internet, right? You just have to pick those SQL queries, execute, and you have data on your time dimension as well, right? So those kind of things. Now let's assume, that is one case where somebody suggested that we can have this as well, which might be useful in the future. Now when you suggested that, somebody from the stakeholder team or the overall group who's part of this design might also contradict, saying that is not defined in the requirement. Why should we do it, right? Now the business can always question, I never asked for it, why did you do it, right? If that is the case, and if the business is there then and there, you can get it clarified. If not, we suggest them saying, this is the best practice, do you want it? Based on yes or no, you either enhance it or leave it as it is. If you can notice the difference, at the conceptual model, we are just saying we need time. At the logical layer, we are going a step further to define what are the attributes which are needed, right? That's the logical model design. Now let's talk about the fourth phase, which is the physical data modeling or the physical model design. Now, this is the final step, or this is the complete model that includes all required tables, columns, the relationships between tables, the database properties for it to be physically implemented at the database level, right? Notice the diagram on the right side, extreme right box. Now, along with the attributes, you also have the data types, which is integer, varchar 30, integer, float, date. Those are already defined, right? Notice the fact sales and the dim date, dim product, dim store. The names which are in the logical model are different. When it comes to the physical implementation, the names are different again, right? We are prefixing all the dimensions with dim underscore and the fact with fact underscore. All right. So that's the difference between the logical one and the physical model. Now, once this model is finalized, this sheet will be given to the database developers or the ETL developers who will create the scripts to create these basic metadata tables or the skeleton system at the database level. Now that is the fifth phase, right, which is the database. Now that's the reason I was saying it is the last phase, or the fourth phase is the last phase, physical data model, because once this is finalized, the only thing which is left out is to create these skeletons on the database level, right? Now either the DBAs or the ETL team will be instructed to use any data modeling tool to create the SQL code from physical data model, if there is any data modeling tool. Else they'll look at this in the same picture, try to create it manually, the scripts, test it, and then execute them, and make sure that these are all created in a reusable fashion. What is reusable fashion? It is not only applicable for the data modeling, for any of your technologies or any of your ETL tools, this can be applied. Whenever you're creating a script which should be executed in the current environment or should be used in your further environments like QA, UAT, and production, make sure you create that as a reusable script, meaning you can run it n number of times, but it will not impact any of the systems. For example, let's say there are 10 tables which are defined in the physical data model, right? 9 tables got created, the 10th one got failed. Now, if you create the script in such a way that you just have create table statements, if you run it again, the first 9 will fail now because the table name already exists. Which means now you have to delete all of them either manually or through some other script and then execute your actual procedure and then figure out what has happened with the 10th table's script and then fix it again, right? That's a manual process. You can do manual processes within your dev environment n number of times. Nobody asks you because it's IT team's environment. But as it goes to higher environments, there would be some other team who will be responsible for deployments, right? As a developer, you would not do the deployment for all the environments, isn't it? So the script should be created in such a way that if a particular entity or if a particular record already exists, then you delete it, else you ignore it. If it is already existing, delete it, create it. If it is not existing already, then you directly create it. Now, depending on the situation, you have to create the scripts in a different pattern, right? If you take another example here, let's say the table already has some data and you're not sure if the data should be dropped. The moment you say drop table, it will drop the table and the data as well. Now you might not have the data, or the QA team has created the data for some test purposes. They might not have scripts, right? Anything is possible. So your script from the IT team or the application development team should be built in such a way that you create a temporary table, take all this data, dump it into the temporary table, drop the original table, recreate it with the original name, take the content from the temporary table, put it onto the original table, and then drop the temporary table. Now this script with all these steps should be done for each and every table, right? That's what is called reusable script. Now you might have to do the same thing for indexes, your primary keys, your views, whatever database objects you create as part of your setup. All of those should be made in reusable fashion. That is the best way to avoid any mistakes during deployment. And the other advantage is that the deployment team can run it n number of times, right? Now they run it, everything gets successful, but for some reason they have to redo it. They can redo it. All it does is it checks if it's existing, then delete. If it does not, then it creates it. All right, that's about the physical data model and the database part.